Good day, or welcome to One-on-One Maths Private Tutors. Today we are looking at this topic, limits of accuracy. This is a follow-up from our previous video where we were doing rounding to a number of given decimal places or to a number of significant figures. So we carry on. By the end of this chapter, we must be able to give an appropriate upper and lower bounds for data given to specified accuracy. Obtain appropriate upper and lower bound to solutions of given problems. What are bounds of measurements? Ali measures the length of a sheet of paper. He says it is 26 centimeters to the nearest centimeter. What does this mean? It means that the length is nearer to 26 than the closest centimeters on each side, 25 and 27. So we can represent this on a number line. 26 is here. We want numbers that are closer to 26 than 27 and 25. Our accuracy is to the nearest centimeter. So we consider the previous centimeter and the next centimeter to 26. And then we want to find what is closest to 26 than 27 and 25. Now, halfway between 26 and 25 is 25.5. And halfway between 26 and 27 is 26.5. Now, we have been rounding up and rounding down. So we can see if we have a value 25.5 and we round it to the nearest centimeter, it will go to 26. So anything from 25.5 going up is closer to 26. And at 26.5, if we round 26.5 up, it will go to 27. But just before 26.5, like 26.49 recurring, should be closer to 26. So using these bounds, upper bound and lower bound there, we can say our measurement, which we can call M, is less than or equal to 25.5. But less than, since by rounding up, we'll go to 27. So we want something that is less than 26.5. So it is important to know the type of inequalities we are using. Here we are using a strict inequality which does not include 26.5. Okay, what is a strict inequality? A strict inequality is an inequality where the inequality symbol is either greater than or less than. That is an inequality which has no equal condition. So if we have less than or equal to or greater or equal to, it's a non-strict inequality. So we use a non-strict inequality there because if we round up 25.5, which will go to 26, at here at 26.5, we use a strict inequality because if we round it off to the nearest centimeter, it will jump to 27. We want closer to 26. So anything just before, an example being 26.49 recurring. Now, 25.5 is called the lower bound. So this is the lower bound. 26.5 is called the upper bound. For the measurement 26, let's look at this question. Paul won the 200-meter race in a time of 24.2 seconds to the nearest tenth of a second. Complete the sentence below. Paul's time was between and so you need a number line like this. 24.2. The accuracy is to 1 decimal place. What is the next decimal place in front and before 24.2? So 24.2, after 24.2, we go to 24.3. Before 24.2 is 24.1. So take note of the accuracy you are given. If it's to 1 decimal place, if it is to the nearest whole number, use that to position your values before and after. Now, if this is 24.1, halfway between 24.1 and 24.2 is 24.15. So this is halfway between, this is our lower bound, and halfway between 24.2 and 24.3 is 24.25. So this is our upper bound. To answer the question now, pause time was between, so it's 24.15 and 24.25. Okay, so this is the lower and upper bound. So for this type of question, I urge you to use a number line. It makes it easier to see. Though it is not a requirement, but it is easier for you. Two kitchen cupboards have widths 300 millimeters and 500 millimeters, correct to the nearest millimeter. So again, this is what we have. 300 is the value. So we want to see the lower bound. So we have 299 before that and 301. Halfway between 299 and 300 is 1, 2, 3, 4, 5. It's there, and it's 299.5. And halfway between 300 and 301 is here, 300.5. Now that is for the 300 millimeter wide cupboard. Now let us consider the 500 millimeter wide cupboard. 500 in the neighborhood, the next millimeter is 501. The previous millimeter is 499, because we are told our accuracy, the nearest millimeter. So halfway between 499 and 500 is 499.5. This is our lower bound. And midway between 500 and 501 is 500.5. That is our upper bound. If the cupboards are put next to each other, so we'll have this 301 next to this 501. We want to find the upper bound and the lower bound, this width. So we are adding this and that for the lower bound. So that is the least width we can expect, 299.5 plus 499.5. This will give us 799 millimeters. So we are expecting a minimum width of 499 millimeters. An upper bound, we expect, if we put them side by side, the maximum width added to this maximum width, 300.5 plus 500.5, which will give us 801 millimeters. So we expect a maximum width of 801. That is upper bound, or 799 lower bound. So the law is to find the lower bound of a sum, add the lower bounds. To find the upper bound of a sum, add the upper bounds. However, the difference between the widths of the kitchen cupboards is largest when the smallest possible width of the smaller cupboard is subtracted from the largest possible width of the larger cupboards. What do we mean? We will get a maximum difference if we subtract this width from that width. That's when we'll get the maximum difference. For the difference, we say maximum of the larger cupboard minus minimum of the smaller cupboard. So our upper bound difference will be 500.5 minus 299.5, which will give us 201 millimeters. For the lower bound of the difference, we will say lower bound of the largest minus upper bound of the smallest, which will be 499.5 minus 300.5, which will give us 199 millimeters. To find the upper bound of a difference, subtract the lower bound of the smaller value from the upper bound of the larger value. To find the lower bound difference, subtract the upper bound of the smaller value from the lower bound of the larger value. A piece of red string is 35.2 centimeters long to the nearest millimeter. A piece of blue string is 12.6 centimeters long to the nearest millimeter. So we have to convert this to millimeters. To convert from centimeters to millimeters, we multiply by 10. So this is 352 millimeters, and this is 126 millimeters. What is the minimum length of the two pieces laid end to end? So we are adding. So let's put our length on a number line. 35.2 centimeters. We'll have 352 there. The next is 353. Before 352 is 351. The lower bound of 352 is 351.5. The upper bound, so this is our lower, our upper bound, 352.5. For our 12.6 centimeters, we have 126 there. The next millimeter is 127. Before that is 125. So the lower bound is halfway between 125 and 126, which is 125.5. That is the lower bound. The upper bound is 126.5. All these are in millimeters. What is the minimum length? When we are adding, add the lower bounds, this and that. So our minimum length will be 351.5 plus 125.5, which is 477 millimeters. But our data were given to centimeters, so we convert this to centimeters, which is 47.7 centimeters. What is the lower bound of the difference in length? So if we want lower bound in difference, we would say the lower bound of the larger value minus the upper bound of the smaller value. Lower bound difference will be equal to 351.5 minus 126.5, which is 225 millimeters, which is equal to 22.5 centimeters. Multiplying and dividing measurement. The measurements of a piece of A4 paper are given as 21.0 centimeters and 29.7 centimeters to the nearest millimeter. What are the upper and lower bounds of the area of the piece of paper? So we have the representation there, 21.0. Before that is to the nearest millimeter, 20.9. And the next millimeter is 21.1. Or we can convert this, for clarity, let us convert this to millimeters. The given is 21.0, which is 210 millimeters, and the next millimeter is 211. Before 210 is 209. That is for the width. For the length, we can convert this to millimeters, which is 297. The next is 298. Before that is 296. Halfway between, we find our lower bound, which is 296.5. Our upper bound is here, which is 297.5. So we have our lower bound, we have our upper bound for the length. For the width, our lower bound for 210 is 209.5. Our upper bound is 210.5. To find the upper bound of the area when multiplying, because area is length times width, multiply the upper bounds. Then we will get the maximum value if we multiply larger values, width and length. That is the upper bound area, which we get as 297.5 times 210.5. This will give us 62,623.75 square millimeters. To find the lower bound area, we multiply the lower bound width times the lower bound length. Lower bound area will be equal to 296.5 times 209.5, which is 62,116.5 square millimeters. We might want to convert this area from square millimeters to square centimeters. So what we have to do is to use ratio 1 centimeter, 1 centimeter. We know 1 square centimeter is equivalent to 1 centimeter times 1 centimeter. But 1 centimeter is 10 millimeters. So 1 square centimeter will be equal to 10 millimeters times 10 millimeters, which is equal to 100 square millimeters. So 1 centimeter squared, or 1 square centimeter, is equal to 100 millimeters squared. So this is the ratio we'll use. What about 62,623.75 square millimeters? Would be more, since this is bigger than that. So if we have a ratio like that, where we have more, the bigger number will go on top. So we have 62,623.75 square millimeters over 100 square millimeters times 1 square centimeter. So millimeters cancel out. 100 into 62,623.75. We'll move the decimal comma 2 times to the left. So now we have 626.2375 centimeter squared. So we can say this is equal to 626.2375 centimeters for our upper bound area. For our lower bound area, we will use the same conversion. 62,116.5 square millimeters will be more, since it is more than 100. So our ratio will be bigger number on top of smaller number, 62,116.5 over 100. All these are square millimeters times 1 square centimeter. Millimeters cancel out. 100 into there, we'll move the decimal point 2 times. Now we have 621.165 square centimeters. So our answer in square centimeters is 621.165. Okay, so we must give back answers in the form they came. If they gave us data in centimeters, our answers must come back in that unit, square centimeters. Let's look at this question. GAN cycles 14.2 kilometers to 3 significant figures in a time of 46 minutes to the nearest minute. What are the upper and lower bounds of his average speed in kilometers per hour? Give your answer to 3 significant figures. Now we have 14.2 kilometers. For distance, the next is 14.3 to 3 significant figures. The previous one is 14.1. So we have 14.1, 14.2, and 14.3. Now we want the lower bound for the distance, which is halfway between 14.1 and 14.2, which is 14.15. That is our lower bound. Our upper bound for 14.2 is 14.25, which is halfway between 14.2 and 14.3. So we have 14.25. Now let's get to time. Time we are given is 46 minutes to the nearest minute. So we'll put our time on the number line 46. The minute before 46 is 45. The minute after 46 is 47. Now we look for the lower bound of 46, which is 45.5. The upper bound is halfway between 46 and 47, which is 46.5. So we're supposed to find the upper and lower bounds of speed in kilometers per hour. So we have kilometers in distance, but our time is in minutes. So we have to convert these to hours. 1 hour is equal to 60 minutes. What about 45.5 minutes? This will be equal to less. So we take the smaller number on top, larger number on bottom, which is 45.5 over 60. So this is equal to 45.5 over 60. Now it's in hours. The same applies for 46.5. So if it's less, you can smaller number on top of the bigger number times 1 hour here. 46.5 over 60 is a minutes times 1 hour. Minutes cancel. So we are left with 46.5 over 60 hours. So 46.5 over 60 in hours. So we have our time in hours and we have our distance in kilometers. So the next thing is to decide which one is the upper and which one is the lower. Now we know speed is equal to distance over time. So to get the maximum, which is the upper, we say upper bound distance over lower bound time. Okay. A bigger number being divided by the smaller number will give us a bigger result. So for our upper bound average speed, we would say 14.25, which is the larger one, over our lower bound time, which is 45.5 over 60, which we obtained from our calculator as 18.791208. This is the carry, but we are only interested in 3 significant figures. Third significant figure is 7, so we look at 9. Ask ourselves, is 9 greater than 5? Yes, it is, so we increase this one, which will give us 18.8 kilometers per hour. 3 significant figures. Don't forget to specify your accuracy. Now, for the lower bounds of his average speed you're looking for, we would want to use the lower bound distance over the upper bound time. A smaller number being divided by a larger number will give us a lower value. So we will say 14.15 over 46.5 over 60. So this is our distance and this is our time, which will give us 18.258. Now we want 3 significant figure. The third significant figure is this one. The next figure is 5 or more, so we'll increase this. We have 18.3 kilometers per hour. 3 significant figures. Thank you.